see it on your screen and accept it that this session is being recorded. Some organizational matters again. During the sessions, your microphones and cameras are deactivated. And in case you want to pose a question or add a comment, please do that through the chat. We are going to moderate the chat and read out loud the questions and comments to the speakers. Yes, who are we? The ones who are reading it out. It's my dear colleague, Martin Thalhammer. You see him there waving at you. He's a PhD candidate at the Central European University here in Vienna. And myself, I'm a PhD researcher at the Department of Social and Cultural Anthropology here at the University of Vienna. And Martin is also part of the core team of the Climate Walk project. And if you're interested in learning more about the Climate Walk project, you can check out their website or listen to the recording of the very first session where they introduced themselves. But now Martin will do a short recap to remind us all at where we currently are on our path in this lecture series.
Yes, thank you very much, Ria. Hello, also very warm welcome from my side. I want to do a very quick recap of last week. So for those of you who have attended, you may remember that we had 4 very interesting, different, but at the same time also complementary speakers. There was anthropologist Tim Ingold, who was scrutinizing walking and even our understanding of the ground. There was the author and publicist Ulrich Grober, who was speaking about how walking could enable us to perceive landmarks of change. There was the historian Ivan Faletti in the second part of our class, who talked about walking as a transcultural experience, something that has, in the form of pilgrimage, actually not changed very much from the medieval to the current times. And then in the very end, we had a meditation teacher and long-distance hiker Ernst Merkinger, who spoke about his experiences whilst walking and even provided a short meditation exercise in the very end. So while last week was all about walking, about the Climate Walk's most central project dimension, today we will hear about relevant climate change related research project under the header of We Listen. The lion's share of them actually revolve around biophysical and geoecological processes related to, caused and amplified by climate change. We will probably hear about the transformation of landscapes. We will hear of peatlands, fluvial ecosystems, and also socio-ecological systems threatened by natural hazards, for example, such as landslides. So yet in the course of the last talk of today's class, we will also hear, and this will broaden our spectrum very much, from an environmental sociologist dealing with the nexus of migration, flight, and environmental change. So a very broad array of different speakers today. One technical remark also I want to make is, for those of you who are unable to access the official Moodle platform because you're not officially students of the University of Vienna, there is now a link to a cloud folder with all the materials and all the readings. I will post this link in some minutes into the chat, and also you can visit our homepage, and in the event section of our homepage you will also find the link that leads you to a public cloud folder that is accessible for everyone. On that note, I will stop here again, and I will hand back over to Ria, who will introduce our first guest speaker today.
Yes, I'm indeed delighted to introduce you to our first guest of the day, Professor Stephan Glatzel. Thank you for being here with us today. He's a professor of geoecology at the Faculty of Geosciences, Geography and Astronomy at the University of Vienna. His main area of expertise is greenhouse gas release and uptake from peatlands. His contribution to peatland and greenhouse gas research is internationally well acknowledged, and most of his above 90 publications, and dear students, all the students indeed know that that is a very impressive number of publications, are on peatland and land use related greenhouse gas research. Professor Stephan Glatzel is also an editor of the international journal Myers and Peat. So thank you for being here today, and we are looking forward to your talk. The microphone and the presentation space is yours for the upcoming 30 minutes.
Okay, thank you, Ria Maria, for the kind introduction. I'll now start sharing the screen, if this is okay. Good. So many screens. Okay, is this fine? Do you see the screen in a nice way? Okay, great. Yeah, so I'm really happy to be able to present peatland issues here in front of this audience. And so I'm not focusing today on what climate change does to the peatlands, but the other way around. What peatlands can do against or for climate change. So I thought this would be a nice switch of perspective, because of course what we do will influence climate change, and how we treat our peatlands influences climate change a great deal, and this is the case I want to make today. So wait a second, yeah, so what a peatland is not a trivial question. What a mire is neither a trivial question. So we have been debating in the community quite a lot about these terms, and the definitions I'm giving you today are the IPCC definitions. So different communities have a different view on mires and peatlands, and the IPCC is the community I'm familiar with, and these of course are the people who focus a lot about climate change and greenhouse gases. So a mire is an ecosystem with peat-forming vegetation. So that's the, there is no good German translation actually. Probably more would be the best translation. So existing peat-forming vegetation where there are plants that actively form peat. But then there's peat land, and a peat land is a soil, regardless of the plant cover or land use, where there are at least 30 centimeters of peat at the top. And peat is a material that consists to at least 30% of organic matter. So this means that if you cultivate maize on a peat soil, you're still working in a peatland. And this, of course, is critical, because our traditional view of mire or peatland would be something like this, right? By the way, this is where we are working. It's a beautiful site in the in Styria in the Alps. So this is a close to natural mire, and underneath the intact peat-forming vegetation, there's a lot of peat. So it's also a peatland. If you take a look at this side, this is from Lake Neusiedl. Below the reed, there is also peat. So systems like this may also be peat forming. This is also a peatland, because there are 30 centimeters of peat at the top. Next picture, I'm going to show you a typical peatland in Austria. No, I don't. I'm not. So a typical peatland in Austria would be a system where there is peat underneath grassland use. So most of the peatlands in Austria are actually not natural, but they are drained and they are being used by agriculture or forestry. This is what peat looks like, in a very generalized way, of course. So at the top, plants accumulate. And the funny thing about peat is they don't decay. At least not all of them decays. because they stay in there. Why do they stay in there? Because it's wet. Because the diffusion of oxygen in water is very slow. That's the reason why water is wet. By the way, that's also the reason if you have an aquarium, you need a kind of a bottle stone to get the oxygen into the water. And since we don't have a bottle stone in the peatland, but it's basically a pretty wet soil, the decomposition of the peat will take place very, very slowly. It will take place more slowly than the plants can grow on top of the peat. For this reason, a peatland grows and grows and grows and accumulates carbon. At the bottom, the bulk density of the peat is higher. That means it's more dense because there's so much weight on top of it. At the top, the atmospheric exchange is higher than at the bottom. So some of the plant material will become eventually CO2, but not all of it. So this is a peat profile here. This is a picture from Lower Saxony, from northwestern Germany. So we can see that at the top, the peat has a sort of a light brown color. And you may see the structure of the peat of the plants at the top. At the bottom, the peat is darker, it's more dense, it has been compacted, and it's sort of dark brown. So this gives us evidence of the compaction situation during the formation of a peatland. This is a graph depicting the carbon cycling in peatlands. Let's look at the upper part of the graph first. So this is a natural peatland. In a natural peatland, the water table is very close to the surface. Everything below the water table is anoxic. Anoxic means there is no oxygen in there. And if there's no oxygen, the decomposition processes don't take place in the oxic matter, which means they're slow. It also means that some methane is being released because the decomposition processes take pathways where methane is being released. So there is a storage of CO2 and there is some release of methane. Methane is a greenhouse gas as well. Methane is 10 times as strong as CO2. So this makes natural peatlands a carbon sink, but not a greenhouse gas sink. Natural peatlands are sort of in an equilibrium with the atmosphere in terms of greenhouse gases. So they store a lot of carbon, which is great. They save carbon, they take it up from the atmosphere, but they also release some methane. So in terms of climate, like radiative forcing, they're sort of neutral. There is also DOC here. DOC means dissolved organic carbon. So there is some like brownish water in the peatland, which usually is not a problem unless you drain the peatland. Then the brownish water comes out of the peatland. The lower part of the graph shows a drained peatland. The water table is much lower. So the anoxic layer is way down. There's a lot of oxic soil, and under oxic conditions, when there is oxygen, you get all kinds of soil animals. You get moles, you get mites, you get spiders, you get earthworms, and especially you get oxic decomposition processes, which means that the carbon will be released very, very quickly. Unfortunately, you still have methane release because in the drainage ditch, the methane being produced in the anoxic layer is being released in the ditch. And you also have the release of dissolved organic carbon, the brown stuff, which eventually on its way to the ocean will also become carbon dioxide. So you are losing a lot of carbon, especially CO2, from a drained peatland. Interestingly, this has been found from many individual measurements, and each point, each dot that we see here is 1 year of data. So when 1 year of data means it's like a PhD student spending a year on the site. So this is a lot of measurements in here. And a couple of these dots are from our group. And we see that the deeper a peatland is drained, the higher the CO2 release. This picture also shows which gases are involved. So it's not just CO2, it's also methane, and it's also nitrous oxide. N2O is nitrous oxide. Nitrous oxide is a greenhouse gas that is being produced when the soil is sort of moist, but not too wet. So for this reason, this blue sketch is a sort of a bump at minus 50 centimeters water table. And if you add these 3 gases, if you add what CO2 does, what nitrous oxide does, and what methane does, then you get a graph that shows, that's on the right side. If you want to have a peatland that does not release any greenhouse gases, the water table should be approximately at the surface, 0 centimeters. If the peatland is flooded, you release methane. If the peatland is drained, you'll release CO2. And the stronger the drainage is, the more CO2 release. So this is not an on-off switch, but it's a very linear function. The deeper you drain, the more greenhouse gases you release. This is from the Global Carbon Project. That's a website I can recommend a lot. Many of you probably know it. So this is a group of researchers reporting the state of carbon cycling and carbon release on the planet every year. And we can see here that the fossil fuels release is going up and up and up, as everybody knows that. But also the land use change carbon release is quite high. It's stable, so it's not going up and up, fortunately, but it's bad enough. It's not going down. So land use is still a big carbon source. And what is the land use? It's mainly currently still, I mean, this is kind of getting strange that it has been like that for such a long time. It's still mainly the clearing of tropical forest. Yeah, it's this is not getting any better, unfortunately. If you look at the land use change CO2 emissions, it becomes very interesting. I mean, you see, it has been going down between the 1960s and 1980s. Since then, it's getting more. And there are some strange dents in this curve. For example, in the year 1997, it's going up, and then the next year it's going down again. And this, this is 2 gigatons CO2 we're talking about in this year, is due to Indonesian peat forest fires. You may have heard about the issues in Southeast Asia, where peat swamp forest, that means tropical rainforest on peat soil, is being cleared, especially for the production of palm oil, but also for other crops. And so a lot of Southeast Asia looks like this now. So this was really started by Suharto in the 1980s. Suharto was the president of Indonesia in these times, and he made a big effort to colonize the big islands of Indonesia. Indonesia is basically 2 overpopulated small islands and 2 big islands which are sparsely populated. And he tried to move the people from the densely populated islands to the sparsely populated islands by draining peatlands on a scale which is unprecedented to produce rice. So this was called the Mega Rice Project. It didn't quite work out, but the damage was done. So the habitats were destroyed, CO2 was being released, and now we are still logging and clearing forest, especially for palm oil production. So this is a picture here from the island of Borneo in October of 2015, where the burning peatlands can be seen. And the main thing is that once the forest is cleared, and when you have an El Nino situation, where the climate, where the weather situation is not as wet as it commonly is, then the peat will ignite, and it will burn under the surface. So you cannot just extinguish it like that. The only way to extinguish these fires is to re-wet the peatlands, get the water up again. So this is Borneo in 2015. And in the year 2015, so this is the data from October 19th, the Indonesian fire greenhouse gas release. So fires don't just produce CO2, they also produce some methane and some N2O, was higher than what all of the nation of Japan produces, and much higher of what Germany produces. So in this situation, 1.75 of 35.7 gigatons of CO2, which is 5% of the global CO2 emissions, just came from these fires in Southeast Asia. So in a bad year, this is even more. This also has consequences for faraway places. For example, this is Singapore in 2015, and this haze was due to the burning peatlands of Southeast Asia. Where are the hotspots of the release of these greenhouse gases? Of course, the biggest hotspot, as we have seen, is in Southeast Asia, 1,000 megatons per year. But the number 2 hotspot is actually the EU. So we Europeans, we shouldn't feel too good about this, because we are actually the second biggest CO2 source from peatlands, from peatland degradation worldwide. So we have a lot of reasons to look at our own peatlands, what to do with them. This is a paper from Jens Leifeld and Lorenzo Menichetti from 2018, and they estimated the greenhouse gas emissions from all peatlands today. So what we can see basically here, we see several things on this map. Where there is like a green or yellow or a red color, that's where peatlands are. So you see that a lot of peatlands are in the north. Everybody knows that. But there are also some peatlands, and actually quite a lot in the tropics. You don't really see the Austrian peatlands on this scale, but we do have peatlands in Austria as well. But what we are seeing is that the peatlands of Southeast Asia are in red or yellow. So that means a lot of CO2 is being released from these peatlands. And we are also seeing that in the Congo and in the Amazon, the peat is still green. This is good. So we really need to take care that the peat in the Congo and in Latin America stays where it is. If you look at, for example, at southern Florida, which is yellow and orange, so the peat is degrading there, and you don't even see Europe on this scale, although it's quite important. The total release of CO2 equivalents, which means that we give a number in terms of CO2 to all the involved greenhouse gases, is 1.9 gigatons. A gigaton is 10 to the 15th grams, so that's quite a lot. So this is number 1, and this is the number 2 source. This is a map of something that we really don't want. We are not that far yet. But the peatlands in the tropics are potential CO2 sources if people like Bolsonaro get their way. The peatlands in the Arctic are potential CO2 sources in case of further permafrost degradation. So we really need to take care that we don't run into a vicious cycle here. How about Austria? There is very little data about the peat area in Austria. This is from the Naturschutzbund, nature conservation people in Austria. So the estimate is that in the last 200 years, Austria lost 90% of its miles. So Austria used to have something like 250,000 hectares of intact peatlands. And now we're down to maybe 21,000 hectares. So Austria has probably lost 90% of the intact peatlands. But the 90% that are not intact are still releasing CO2 because they're under forestry or they're under agriculture. So we don't know because nobody has measured it. We tried to measure it, but we were not very far yet. And so the estimate is that on the scale of about 1 million tons of CO2 per year are being released from Austrian peatlands. Is this a lot, 1 million tons? Well, that's like 1% or 2% of the total greenhouse gas emission from Austria. This is not like the biggest part, 1 or 2%, but it's a part that has not been addressed so far in politics. So this is what we want to change. So what do we do? Like, are there no alternatives? Of course there are. This is why I'm giving this talk, right? So what we need to do, we need to turn a site like that, which releases approximately 50 tons of CO2 equivalents per hectare and year. So 1 hectare releases like 50 tons of CO2. That's quite a lot. 1 hectare is not a big area. That's 2 football fields. And turn that back into a site that does not release CO2. So by re-wetting, we can gain, mitigate 50 tons of CO2 per hectare in a year. So how do we do this? I mean, there are established procedures for many settings, and if attainable, this is the best solution. So this is relatively easy. If we look at the table from the Leifeld and Menichetti paper, we see where the actual emissions are from. You see, in the tropics, 1.48 gigatons, so that's the biggest part. In the temperate zone, it's more like 0.16 gigatons. In the boreal zone, it's 0.26 gigatons. That adds up to 1.91 gigatons. We can mitigate 5% of the global greenhouse gas emissions if we address the issue of degrading peatlands. Or, also a nice idea, we can overcome the hunter-gatherer culture we are living in. So currently what we are doing, we're exploiting material that has accumulated over decades, centuries, millennia, all the fossil fuels, or all the peat, until the site is exploited, and then we're moving to the next site which we can destroy. This is what we are doing with peatlands currently. So also an issue would be to establish agricultural use of peatlands without destroying them. For example, something that we call paludiculture. This is a site I have been part on, where we are producing peat moss on bog peat. Actually, the peat moss is being harvested and then it regrows. So this would be a nice idea if we pass the hunter-gatherer stage finally. So how can we reduce the greenhouse gas release from peat soils? Well, we have to stop drainage. This is the site where we work in. So you can see the natural, the close to natural part. This is the forest and the open bog. So this is a nature conservation area, but you can see the grassland all around it. The grassland is on the same soil, but it's drained. Fortunately, this session of drainage is not like a on-off switch. So we can have all kinds of solutions in between. If the water table is maybe minus 20 centimeters, then we still have very little CO2 emissions. But between let's say 20 centimeters and 50 centimeters of water table, we are getting a much higher CO2 release by increasing the drainage. So we can work on extensive land use. Of course, then we will not produce as much milk. Yes, this means maybe not eat as much meat, maybe don't export the milk to China, which is what we are doing. I mean, this raises questions, right? We need to report the peat soil and the emissions. Actually, we're not doing this currently. Currently, in the national inventory report, we are not reporting all the CO2 release and the greenhouse gas release from the peat soils in most countries. Switzerland is one of the few countries which has succeeded in locating its organic soils for the Swiss greenhouse gas inventory. We are now working on doing that for Austria as well. So it's easy, but on the other hand, it's also quite hard. Natural green peatlands, they store some CO2, but they release some methane. But drained peatlands release so much more CO2. I'm sorry, this number is actually wrong. I need to correct this at once because this would be a big mistake showing the wrong number to you. There you go. So 1.1 gigatons per CO2. Excuse me, now I did a mistake here. Let me share this again. Here we are. Yeah, 1.1 gigatons CO2 worldwide, 5% of the global emissions. So what can you do about this? Well, agricultural policy, of course, is the key. What do we subsidize agriculture for? And we do subsidize agriculture. So this needs to be negotiated on the national and in the EU level and on the international level, of course. In the end, this is an issue of incentives and values. What is important to us? The role of consumers. What do we eat? How much are we able or willing to pay for what we eat and drink? And in the end, this is an issue of civil society. This should not be a top-down effort. So if civil society decides that it wants to implement these values and these incentives, then this is the most important step to change. Yeah, so thank you for your attention. Hope for some discussion. We have 8 or 7 minutes left. Thank you.
Thank you so much. I assume that many of us were not aware of the ecological importance of the peatlands. As myself, I mean, I include myself into that, and it was so nice how you brought the global aspect, but then also the local. What does it mean for us here in Austria? And let's see, the students can now, you're now free to post questions into the chat. Let's see how I can open. Okay, now I have the chat open here. I think it's so nice as a social scientist, we often don't think that much, you know, of the numbers or percentages or look what's beneath the earth. We look at the people and that aspect of how people react to those things. So it was, I think it's so important to also look sometimes from that other perspective, of the perspective of natural scientists, what is happening when we talk about climate change.
Yeah, and I think, I mean, this is why Climate Walkers is such a great initiative. I mean, this is basically a bottom-up effort of students and people concerned about their future. And we need strong and many efforts like that, bottom-up efforts to work on these values, to work on the things that will force the economy and politics to implement changes. But if the politics and the economy, if they don't see that this pressure is there, then of course there's no pressure to act. So this is great. Yeah.
I would have a question in the meantime.
Sure.
Thank you very much for the very interesting talk. I was thinking maybe, how are the efforts in Austria going when it comes to re-wetting, drained peatlands? Are there any successful examples of how we could re-wet and maybe you could mention some of them? I would be very interested to hear about that.
Actually, the re-wetting part is the relatively easy part. Yeah, so I mean, wherever there are peatlands and meadows in Austria, like in Waldviertel, in the Alps, there are many. There's a reasonably large and well-working effort to re-wet the close to natural meadows, which is great. But this is 10% of the area. The tricky part is the 90% under agriculture and forest, because this is where tough choices will have to be made. And of course, the farmers are not evil people. The farmers they have a family, they make a living, they want to continue to make a living. They've been living on this land for centuries. And so I think we need to provide them with land use alternatives. And these alternatives will need to be financed, which means they need to be economically viable. Mm-hmm. So that's the issue. That's why we are also working on these paludicultures, on these alternatives to continue doing agriculture, but without drainage. So this is the tough part. But there are re-wetting efforts in the close to natural meadows in all parts of Austria. But we also have lost a lot. For example, south of Vienna, in the so-called Feuchte Ebene, so going towards Wiener Neustadt, that used to be an area with a lot of peatlands, but now they're gone due to drainage. But fortunately, the perception of the natural meadows is now very good, and the local efforts for local nature conservation efforts everywhere in Austria. And so this re-wetting works in many places, but climate change is threatening this re-wetting. Because especially in Waldviertel, for example, precipitation rates are going down. So this used to be an area with more than 800 millimeters of precipitation, and now we are more like at 600. Mm-hmm. And 600 millimeters is not enough to maintain a bog. So this is another issue. So climate change itself is threatening the peatlands.
Thank you. I think we have so many questions coming in that we have to start answering them in the chat, and I will read out the first two now. So Dikla Sharon asks, what is the contribution effect of Arctic permafrost defrosting to the GHG global emission state, and is there anything we can do there, assuming flooding the Arctic is not realistic? And then I'll also add the second one. It's not an Arctic question, but then we go to the rainforest part, and Samantha asks that, could you please explain the rainforest and the peatland in reference to palm oil again? How much is altered? How much production of palm oil is there annually, and what's the CO2 emission relative to that?
Okay, so the Arctic peatlands, there's a lot of research about what happens when permafrost in the Arctic thaws, and the peat soils, which are in the top meter or 2 meters of these of this thawing permafrost, will release a lot of methane. So currently, this is not the focus of greenhouse gas release in the Arctic. And it's not the focus of greenhouse gas release of peatlands worldwide. So I don't know the number by heart, but it's not the focus. You've seen this map from the Leifeld and Meniketti paper. It is much lower than what we are experiencing in the tropics, and also what we are experiencing in the temperate zone. So this is a real danger. because it's a classical vicious cycle and a positive feedback. But this positive feedback has not become, at this point, it is not a big issue yet. But the Arctic is warming much faster than other parts of the globe. So this is a real danger then that these peatlands will become a big source of CO2 and methane, but they are not at this point. The palm oil question, well, I mean, in many, not in all, but in some, and I would even say in many tropical forests, the soil underneath the forest is peat. Depends on where you are. The tropics are not uniform. Everybody has the idea of the tropics, it's our rainforest. Yes, it may be our rainforest in the humid tropics, but there are peaty areas and non-peaty areas. And where there is peat, and a lot of peat you got in Southeast Asia, Malaysia, Indonesia, the forest has been cut, the peat has been drained, and on the peat soil, a plant which grows very nicely on a peat soil is the oil palm. It's a culture crop. It grows very nicely on the peat soil. It produces a great product, palm oil. Palm oil is used for everything. So whenever you eat processed food, there's going to be palm oil in it, in margarine, in Nutella, in so many things. Since it's also a cash crop, the people who produce this crop make a lot of money. And one detrimental effect of this production of palm oil by draining the soil is the release of 1.48 gigatons of carbon per year. 1.48 gigatons, this is a lot. So that's the price you pay. Of course, we are paying that price, but the companies who are producing that and the governments who are giving the okay for that production, they're not paying the price.
I think that's also like, I just read Elena's question here, and she asked a very practical question my question is to still use peatlands for human consumption. What are the alternative products of efforts to keep using them? Is that then to just avoid palm oil basically, or what would be a quick answer?
I mean, palm oil is the prime example, but there's acacia production, for example. There are other crops which are harmful that are produced. It's not just palm oil. But these paludicultures, I think, are a key. Okay, what are the other crops you could produce? I did show, but that only will work in the north. It may work in Austria. We want to try it. Is peat moss, which so many people use for gardening. Then there is a couple of crops that can serve as building material or as a material for insulating. So these are plants we call halophytes, plants like Typha, Phragmites, some Carex species, some sedges. So these are fast-growing plants that we get in fens, Niedermoore in German. And they serve as a building material, they serve as insulation material. So the industrial processes that we have need to integrate these products into their production. Also, you can burn these plants. You can turn them into pellets, and they're going to serve as a bioenergy crop. We have also, in many areas in the rich world, especially, these fen soils are oversaturated with nutrients, too much nitrogen and too much phosphorus. So the nice thing is these plants take up nitrogen and phosphorus, so they also help to clean the water. Then there is Alnus, the alder in English, the alder in German Erle. It's a tree. It's a tree that grows in very wet areas. It produces excellent wood. So there are products that can be grown on a wet peat soil that can provide a living and a livelihood to the people living there and living off the land. And the markets are sometimes available, for example, for alder wood, but for other products, we need to develop them. So we need initiatives turning the products into turning the agricultural products into things that you can buy in the supermarket. We are in contact with Bella Flora. We are in contact with big hardware stores. So I think this needs to be demand driven. So this is not an issue that can only be done by ecologists. It needs to be done by people selling things.
True. Thank you. I think we are running out of time, but I think maybe there is a quick answer to this question, and then we'll move on to the next one. Jiri asked that why, do you know why there are so many fires in Indonesia, but not in Central Africa and South America? Is there a quick question to that? Quick answer, sorry.
Well, the Congo is not developed yet, developed in our Western sense. So that's the reason. The Congo is in a very difficult situation, as everybody knows. And so it has not, in our Western industrialized sense, been developed. South America, there is a lot happening there, of course, but the main forest clearing is on mineral soils. And the PT soils in South America are in the center of the Amazon basin. And their forest clearing has not been taking place on a large scale, fortunately. I don't know why this is different in Southeast Asia, but I that Suharto actually plays a big role. So in the former president of Indonesia, who had this vision for his country, and he did the forest clearing and the redistribution of the population from his many islands on a really large scale. So I think he started something here. So one person makes a difference. Yeah.
Okay, thank you very much. You can see if you go to the chat as well, you can see all the rest of the questions that have been there. And I think partly they have been answered already through the answers to the other questions.
While the next talk is on, I can answer the chat in the chat.
Yeah, that would be really nice of you if you would
do this. Thank you.
Shortly. Thank you so much. And I'll give now over to Martin.
Thank you very much for this interesting talk, also for the discussion, for bringing up these all interesting points. Against the background of a now very similar disciplinary alignment, somehow we continue with our next speaker, Jan Hradecký. Jan Radetsky is Associate Professor in Physical Geography and Geoecology at the Faculty of Science, University of Ostrava. He has been the head of the Department of Physical Geography and Geoecology from 2011 till 2015. From 2015, he is Dean of the Faculty of Science. His principal field of interest is slope and fluvial geomorphology, landscape evolution, and interdisciplinary approaches used in geomorphological and geoecological research. He collaborates with various institutions on adaptive approaches as part of the management of protected areas for global climate change. At present, he is leader of a project which aims to prepare measures to improve the hydromorphological condition of the lower section of the Elbe River in the Czech Republic. And on this note, thank you very much for being here today, Jan, and the stage is yours.
Okay, thank you very much for invitation. It's a pleasure to be here and to take part in this very nice transdisciplinary project. So I'm starting to share my presentation, and I hope that you will see this presentation. Is it okay? Okay. So, okay. At the beginning, I would like to say that I would like to present some results of our research and maybe some things about our philosophy and thinking about climate change and adaptive approaches in our region. So it will be focused regionally, not globally, but regionally, and I think it's a very important level of our thinking about climate change too. So I would like to speak about impacts of climate change on the ecosystems, especially on forest ecosystem and on river ecosystems, because these two ecosystems are very typical and very important for this study area, which are Czech Carpathians, but only a small part of Czech Carpathians, which is called Beskedy Mountains. And as I saw in your plans of your walk, you will spend some time in Beskedy Mountains. So I hope that we will meet in terrain in the field, and we can discuss directly about the changes in our region. So firstly, I would like to say several words about one very important topic: why to study effects of climate change in the Beskedy Mountains. What are climate change scenarios in this area? It's very important for the starting discussion of adaptation or some mitigations. And how will these changes affect the structure and functioning of ecosystems? And of course, what can we do against or how can we adapt to these changes in the future? So some words about localization. Moravsky Silesian Beskedy Mountains are a small part of a huge Carpathian belt, which is part of Carpatho-Alpine system in Europe, and this is Ostrava, the third largest city in the Czech Republic, and this area is densely populated. Close to Beskedy Mountains live approximately 1 million inhabitants, and of course, these ecosystems are very important for people close to the mountains, because, as you know, there exists some theory of ecosystem services or ecosystem functions, not only in the point of view of economic strategies and economic exploitation of landscape, but of course that very important and core thinking about ecosystem services are different than economic functions of landscape and ecosystems. So if we see Beskedy Mountains, we can say that there are some brings into the mountains, for example, tourism and pressure due to recreational activities, and there are some brings out the mountain region, as for example water and wood and other commodities from this ecosystem. So I think that it's evident that there are some conflicts or possible conflicts with the use of this area of this ecosystem services. Some basic facts about Czech Carpathians, or generally about Moravsky Silesian Beskedy Mountains. It's typical that they are composed of sandstone and clay stones as a result of geological evolution. And it's not so important for this moment, but it's very important for the creation habitats and sites for different ecotopes. So we must think about some geological prerequisites in this area. And I mentioned that this area is composed from, for example, sandstones, and this area could be very easily affected by drafts, because as you know, for example, weathered sandstones are very well drainaged, so water very quickly goes down. So And next very important feature of this area is that this area is affected by landslides. I think that Thomas Glade will speak about landslides next talk. And sometimes this area is called as landslide landscape, because landslides are very, very typical for this area. There are some pictures from this area. Typical is that almost 80% of this area is covered by forest, but this forest is predominantly spruce forest. It's not natural forest, but cultural forest, or forest which is planted for wood, especially. But there are some remnants of very nice places with protected, covered by protected areas, small protected areas with the natural forest. And of course, meadows and mosaic of different kind of vegetation is there too. I think that one very important conflict of interest is connected with the philosophy of nature and landscape protection. I think about this is very huge discussion I think all around the world. There is one very classical paradigm of nature protection to protect some area for wild species, and especially a strong emphasis on endangered species, and therefore we establish protected areas, especially national parks. But there are another, I think, conservation paradigm very strong to protect the environment for wildlife, but at the same time to protect the function of ecosystem with regard to needs of society because of ecosystem services, etc. Both paradigms, I think, are in contrary to classical economic use of the area, which seems to be unstable and due to ecosystem functions of the landscape, and it's a big problem for the future. Very nice example, I think, of these 2 or 3 paradigms how to use or exploit landscape is visible on this ecosystem services of river landscape. There are some current trends. You can see that all is moved to the exploitation of functions of landscape, hydropower, and so on. Another approach is environmental protection scenario with a more pressure to or pushing to the cultural services, regulating services, supporting services, and so on. But we try to find some balancing trade-offs, but maybe it's a utopia. I don't know, but it's very complicated story and very complicated topic. So why we try to find some new concepts for our study area is it's proud from history of this area, because this area was characterized in the past by very extensive forest ecosystems, natural forest ecosystems, until Wallachian colonization, but from the 16th to the 17th century, Wallachians came to this area, and completely transformation of this area started. It's very well visible, I think, on these pictures. You can see on the left side natural forest, and after Wallachian colonization, transformation to the meadows and to the pastures for grazing forests and pastures. It's very well visible on this pollen diagram. We made some analysis in peatlands, which are located directly in the old landslide areas. And you can see that this the result of Wallachian transformation is very well visible on these diagrams, because typical forest was composed of beech and fir. And after Wallachian colonization, you can see on the left side, it's the first left circle, the declination of this species and enlarging of meadows, which is represented especially by herbs. Yeah, it's very well visible from this archive, Peatland archive. Another very important phase started at the turn of 18th and 19th century, when industrial production began, and it's connected with Ostrava, because Ostrava is very well known for coal mining and machinery and iron works. And what was important that there was a huge demand for wood. So after that, starting controlled afforestation, we were part of Austrian monarchy, and this was a classical trend in all Austrian monarchies. So afforestation were started during this area. And we can represent the transformation of water basins, watersheds very well. You can see, for example, picture from the half of 19th century of Moravka River Basin, and nowadays you can see that the area is completely afforested. And a very important phase started in the 17th of 20th century. We met with huge effects of air pollution. It was a big problem in this area due to close of industrial area of Ostrava, but not only Ostrava, but Poland and so on. And the result was a massive destruction of forest complexes. Complete total with very huge transformation, for example, of soils, acidification of forest soils, and so on. And all these things were multiplied by the bark beetle calamity. Yeah, it was result of the very fragile ecosystem located in the area. Nowadays, we are in the same situation because very dry years, last three years, started a new calamity of bark beetle again. So we are in the same situation like in 70s. So very important information is that, as I said, forests in this area are not natural, but cultural, and we can say that we met with forest industry, and this forest industry, the result of this forest industry is that 70% of forest is composed of spruce. Very unstable monocultures, one age, large areas covered by the stands of the same age. So therefore, we started thinking about this situation and about the future with the connotation of climate change. And it's evident that these spruce stands, spruce forests are planted on different habitats, on habitats, ecotopes, which are not primary, or these ecotopes weren't primarily covered by forest stands. So a big problem for the future. Some information about streams. It's another story, very complicated. This area is very important as a source of water, and there are springs of very important rivers for this region. Typically, in the higher position of mountains, we can meet with high gradient water course. And in the 18th and 19th century, the energy of water curves began to use. There were established, for example, float of wood and hammers and so on. And what is important that Carpathian rivers are or were and maybe will be very dangerous for people because they are a source of flood risk. So from the beginning of 20th century, the regulation of water courses began. I think very hard, very strict regulation, straightening and narrowing and building of water dams and so on. So it was a big problem, and the geomorphological and hydrological regime of Carpathians rivers was significantly influenced by these anthropogenic activities and completely transformed the situation of watersheds. There are some examples: natural streams, high gradient streams, and anthropogenically transformed streams. This was excellent example of natural stream regime under or inside wider valleys in the Beskid Mountains. You can see unbranching rivers full of gravels and so on, but due to watershed activities, these rivers were completely transformed, and this is one result of this transformation. Huge erosion, very incised rivers. And we can think about situation of climate change, higher evapotranspiration, maybe lower precipitation, and we have drained landscape. So these transformations of rivers is typical example of anthropogenically induced draining of landscape. So and we can speak, of course, about soil erosion in the forest and so on, because due to bark beetle calamity, there was established new roads, forest roads, and they are source of soil erosion. There is one example of straightening, a very extreme example of river regulation in this area, and of course water dams. So, and we compare this state of our landscape, our ecosystem, with predictions, with some climatic models. We use Hradecký model with two variants. One variant is with a lower concentration of CO2. One is with a higher concentration of CO2. And we use three periods for scenarios or predictions. One period is from 2021 to 2040, the second period 2041 to 2060, and from 2081 to 2100 is the third period. So, and we compare these scenarios with the situation of our ecosystems. There are some basic information, typical station or data, climatic data for typical station, which is located in the approximately 500 meters above sea level, and you can see average temperature 7 degrees centigrades is annual average. And for example, the highest point of Moravskoslezské Beskydy Mountains, Lysá Hora Mount, there is annual average temperature approximately 2.5 centigrades. So, and annual, another very important climatic characteristic is, of course, precipitation. And you can see annual average for Velké Karlovice, approximately 1,000 millimeters per year. Lysá Hora, more than 1,300 millimeters per year. So what can we say about some conclusions or interpretations of climate scenarios? We can say some words about temperature, that we can observe a gradual increase of average annual temperature by about 2 or 3 centigrades to 2060. Gradual increase of springs, especially summer temperatures, up to 2 centigrades, significantly increasing number of summer and tropical days, and gradually decreasing number of frost and ice days. It's very important for snow cover, for example, during winter, and as a very important source of water for our dams in this area. So there are some maps, and you can see there is a comparison of the first period with the second period, and you can see that areas which are now colder or the coldest in these mountains were shrinked. These areas will be reduced very importantly, I think. There are summer temperature averages, the same situation. We can say that hot waves and hot periods during summer will be really very extreme. And situation with precipitation, there is one good thing and one bad. One good thing is that we do not wait that precipitation will be lower. We think that balance will be the same, approximately same as now, or during the last 20 years. But distribution of water, distribution of precipitation will be completely different, and I will talk about it a little bit later. So we can say that slightly increasing numbers of days with higher torrential, especially torrential precipitation. This type of precipitation is very dangerous, very dangerous due to flash floods, for example. Gradual decrease in amount of snow and reduction of number of days with snow cover. It's bad news. And reduction of flows in water streams. It's not good news for hydrobiocenosis, because it will be very critical situation during dry seasons and during some drought periods, and extending of length of growing season. And of course, with climate change in this area are connected extremes. Meteorological extremes, more frequent occurrence, for example, of storms, windstorms, hails, assumption of slightly increasing number of days with higher torrential precipitation, as I mentioned in the last slide, and higher risk of fires. it could be a big problem, because now with fires we have no problem in this area. But during droughts and if the landscape will be drained, it could be a big problem. So what can we say about prognosis of changes in within spruce forest? We can say that all these green areas where now is spruce forest located will be completely vulnerable and completely transformed due to climate change. Very important question is how altitudinal vegetation zones will move after when temperature grow up. And you can see a situation which is typical for nowadays, that very typical is Fear Beach zone, which is still dominant. We are speaking about natural zones, about natural vegetation zones. Of course, these zones are covered by spruce, yes. But after models, we can say for the last period of this scenario that natural higher altitudinal zones are completely missing. So we can say that we lost typical azonal boreal coniferous forest in the future due to climate change. And zones are completely shifted. Beach zone is located on the tops, and oak beach zone is dominant. Now is dominant, especially in the lower parts of our area. So we can say that total vulnerability of forests to climate change is visible on this slide, on this map. Is on the most area is very high. So. And we tried, of course, to do some modelations on not only forests, but habitats for some species. There is model for one type of forest. This forest is typical example of continental boreal coniferous forest. And you can see on the left side of this slide, the green zones are with the good conditions for this kind of forest. And on the right side, in the second period, we can say that all these sites will be in the bad conditions for this kind of forest. So. And there is modeling for habitat for one species, typical species. It's how to say one example of bio indication, and this is moss, one type of moss, and you can see that this moss which is very for this species very important wet and shade conditions that typical habitats were missing during this period. So two rivers. You can see contemporary situation with precipitation and temperatures. And it's very important to say that in the second part of studied timeline, we can say that precipitation will be a little bit lower, approximately 1/5 of contemporary precipitation. And much more important is, we think, shifting of precipitation seasons. You can see this black line is current situation, and these blue lines represent situations in 2030, 50, and 90. And you can see that there will be a relatively long period without or with lower precipitation. It could be a problem, especially for flow, discharge in our streams. And we modeled this discharge with comparison with nowadays. And you can see that, for example, in Lomná River, Mohelnice River, we see that average discharge will be approximately 25% lower than nowadays. It will be very, I think it will be problem for our dams, for our reservoirs, how to fill these reservoirs with water. And we do our colleagues, hydrobiologists, do analysis connected with transformation of hydrobiocenosis. And we can say that we lost some typical species of our torrential river ecosystems. For example, these two. So, what can we do for the future? We can resignate on these scenarios, or we can find some adaptations. Like this guy in Slovakia during floods. So we can think about some approaches. What can we do is construct some way how to find transformation, how to describe intensity of these transformation processes, and to give some proposals of measures for inclusion in the management rules. And I would like to show you some very nice examples from our area, how to keep water, for example, in landscape. This is from arable land, close to studied area. You can see intensively used arable land. And after one project, it was completely transformed into the wetlands. And it's caused bird meadows close to Ostrava. It's one very nice example how to keep water in the landscape. And another one I think very important is to think about these processes and future together with all stakeholders. I think that a very important role in this play NGOs, organizations, especially oriented on, for example, forest management and meadow management and so on. And we have some very nice examples from Beskid Mountains. Two conclusions. I think that some effects of climate change are very rapid, especially in water streams, for example, such as effect of dry seasons. However, ecosystems in many cases respond to climate change with some delay, and land protected area, Beskid, represent in many cases very fragile and vulnerable ecosystems, mainly due to long-term anthropogenic stress, as we saw in the several slides. And we expect fundamental changes in the species composition of the forest and shift of altitudinal zones, and we must completely transform forest management. So we must start plant completely different species, and we must completely change thinking of foresters or forest managers, and completely transform forestry policy in Czech Republic. A relatively rapid response to climate change can be expected, especially in hydrobiocenosis. But all these prognoses are based, of course, on evidence-based knowledge, but many processes are still not good understood. So therefore, it will be very crucial to compare how ecosystem response forecasts will fit reality in 50 or 100 years. So one recommendation to walkers or for walkers: if you go through the Czech Republic, we published 3 years ago book about landscapes and landforms of the Czech Republic. So you can use it as a guide for your trip through the Czech Republic. And I wish you a good journey and successful project. Thank you very much for attention.
Thank you very much, Jan. Thank you for this stunning presentation, actually with a lot of, like somehow horrifying outlooks of how things will change and how landscapes will soon change. But at the same time, we have the possibility also of adaptation. Maybe we just take 1 or 2 very short questions, because we're already over the time and we also want to have people to have some kind of break in between the 2 slots. Are there any questions from the audience? Short ones. If not directly, I would have a question also out of personal interest, because I'm also doing currently research on the bark beetle situation in Upper Austria. And I was just curious, like, are there already efforts, to change the forest species composition in your region? What is happening there? Is there, large scale logging interventions, or do people just try to support the natural rejuvenation processes or something like that? Maybe you can tell us a little bit about what is happening in the forests currently.
Mm-hmm. At this moment, I think that forestry policy is to plant different species. We start with deciduous trees, especially beech, which in the lower parts and upper parts will be, I think, good choice. And for the lower parts, they use especially oak. So I think that strategy that colleagues from forest faculty from Brno prepared some manual how to manage afforestation of our mountain regions after this beetle bark calamity.
Okay, thank you very much. Let's see if there are, what we can also offer you, if there are questions coming up in, during the break, maybe you just write them into the chat, and maybe Janis is still here, maybe for a little bit, and so he can see if there are some questions coming up. If not, thank you very much again for being here. Thank you for the stunning presentation. Thank you for supporting us, and we will be really glad to visit you in the field, directly in the mountains. We will now do a 12-minute break, so we will reconvene at 6:30, so at 18:30, with another stunning talk. And we wish you a pleasant break, and see you soon then afterwards. Thank you again for being here, Stephan Glatzel and Jan Radetsky, and yeah, we will see each other soon.
I think it's always, oh, okay, sorry, the recording was started again. Yeah, welcome back from the break. It's a little bit hard to say who is back, because we can only see these names and the black squares, but we hope that you're all listening there, because we have another exciting guest here tonight. And actually, it's my pleasure to introduce him right now, the third guest of the day, and he's Professor Thomas Glade, and he is a professor at the Department of Geography and Regional Research at the University of Vienna. He's also the head of the department's working group titled Engage, Geomorphological Systems and Risk Research. And he's an expert in the areas of geomorphology and natural hazards research, particularly focusing on landslides, risk governance, and assessments of climate change impacts in different regions of the world. He has also published extensively on issues such as landslides, soil erosion, periglacial processes, and the human impact on natural systems. And he's also a member in the extended editorial boards of several renowned scientific journals. So the next 30 minutes, the microphone and the virtual stage is yours.
Okay, Ria, thanks a lot for the very kind invitation, and welcome also from my side. And I really appreciate that you're here with me at this time of the day. So it's really good, and also my congratulations to all the organizers of these talks. It's a really good initiative. Yeah, so it's my pleasure to talk to you today now in the next 30 minutes. That I'm allowed to give you a little bit my view on climate change and environmental risks. I'm just sharing the screen with you, and I hope it does work, does it? Martin, I can see you. Is that working?
Not yet. Yes, now it's working.
Now it's
Perfect.
working. Okay, good. Perfect. Yeah. So thanks a lot. So this is the talks of today, and yeah, we will go into that and dive into that. Good. So the key issues I would like to address now. I would like to set the scene a little bit in terms of climate change, but also in terms of environmental risks. I would like to go a little bit then further and highlighting the issue of human impact. And I would like to link that finally to global dimensions. Finally, I have some take-home messages for you, which you can take or not. Good. So climate change, I think this is sort of one of the photographs, which is, which you find everywhere. Some very extreme images to explore and transport the importance of the situation. Indeed, the greenhouse effect is highly important in that respect. So we have the incoming radiation, shortwave radiation with high energy, and then the reflection of that. And then you have in the middle this pinkish area, where you have the greenhouses and where you have the greenhouse effect. The central effect actually of these greenhouse gases is that they do not heavily influence the incoming waves, which is good, because otherwise we couldn't survive on our Earth. But they reduce significantly the long wave radiation reflected from the Earth. And there are different type of gases, and Stephan and Jan mentioned already some of them and related their work towards these gases. And I'm sure that the others also, other presentators have also linked to that gases as well. And indeed, we have these developments here, different graphics. There are trends, definitely here from the mid of the 19th century until now. And here it is given the temperature anomaly. And on the top one, you have this temperature anomaly from 1900 to 2010. And in the lower graph, the authors tried to differentiate between the human impact and the modeled one. So the black line is sort of the measured one, and the blue line on top, in the top graphic, is the natural anthropogenic impact, and in the lower one, it's purely the natural conditions. And you can clearly see and identify that this increase is in particular related to this human impact, which defines the importance of climate change. And if you relate that to greenhouse gases, you also realize that you have some forcings and some influences on the different greenhouse gases, which are here with different colors. And you have here influences of us, of the humans, on these gases and on the contributions in the atmosphere. And in principle, these gases are really good. They are important. Without these gases, we could not survive. People sometimes forget that. So the greenhouse effect is good for our Earth, okay? Otherwise, we would have sort of very, very high temperatures when we are sort of exposed to the sun, and very, very cold temperatures during night when we are not exposed to the sun. But because we have our great atmosphere, and because we have the greenhouse effect, yeah, it levels sort of these temperature differences, okay? And the different type of gases have different roles in the climate change. However, it is obvious that these different types have their importance. Okay, I will stop there. This will continue. My main message is that in the previous graphs here, you have seen this increase for the global view, but we have definitely to differentiate, okay? We have to differentiate over a given year. We have to differentiate as well on the globe in different parts of the world, okay? So it is really, really tricky to really investigate the climate change. And we will come back to that point, this very important point, when we talk about the environmental risks in a minute, okay? Nevertheless, we have global effects, like here, an example in China, with the pollution of air, and also the effects, for example, here in Wuhan, where the pandemic started. And in the upper part, there was the pollutants in Wuhan in China before everything was stopped, more or less, before there was a big lockdown. And then in the lower graphics in 2020, when sort of there was a big sort of lockdown also in China, you really can see the huge change in NO2 density in the troposphere. This shows you we have a major input on our climate, no doubt. And this is again showing here in these hockey stick graphs. So here from 900 until 2006, these fluctuations, sort of the natural fluctuations until until more or less 1800, and then these increase. Yeah. Okay, good. That's setting the scene in the climate change. Yeah, I do not want to explore that further because my topic is in particular related to the environmental risks. Because in the environment, we're having also challenges which we have to face. And I would like to explore that a little bit. So we have indeed some, I would call them very nice landslides. So big features which are here sort of deposited and marked here with a dashed yellow line. An example here of China. Smaller ones, for example, in New Zealand, you can see these grayish area. It's an earth flow which blocked the river with an adjacent blockage of or creation of the water reservoir, which has the danger of breaking through and causing a flood. So you realize you might have climate change issues in terms of increased precipitation, stronger storms, which cause an earth flow, then a cascading effect, which blocks the river, you create a reservoir, which might cause a flash flood, okay? And you don't only have these as a single events, you might also have thousands and 10,000s of these type of landslides of different sizes as well. Also, these are examples from New Zealand from a really, really big rainstorm event when some areas more than 50%, so 50% of the area just slipped. But you might also have just very small events in terms of sizes, but with huge impact. Here, for example, there's just a single rockfall, not really large. Well, you don't want to get hurt from it, but not too large actually. But if you consider the impact, okay, this railway line was blocked for a couple of months, and there was a railway traffic which had sort of a transport of every 3 to 4 minutes with a big truckload of a good railway. Okay, so huge impact in terms of risks, huge consequences. So very small process, very small rockfall, but huge implications. Yeah. Think about the floods, yeah, which we experience worldwide, also here in Austria, where you're sort of draining the houses, and also here, this interaction between the nature, between the floods and the society. This is the key issue. And we always have to think about systems. So you have these wonderful landscapes here, and these are interactions. So the slope interacts with the foot of the slope, with the river course, with the lakes, with the adjacent rivers, and possibly even with the oceans. And you have different types of these coupled environmental systems. Yeah, they interact. And this is very important to consider when you talk about environmental systems and when you think about the influence of climate change for the whole systems, okay? Because these are coupled. We have also human interventions. On the bottom left, you can see the green meadow, which is irrigated areas in these parts. You also have lots of chemicals which are brought in there. And therefore, these are coupled environmental systems also along coasts. The coasts are highly determined, for example, by the bed load, which is brought in through the rivers. And when you change the river system, for example, when you build reservoirs, you hold back the bed load of the rivers. These stones, this gravel does not reach the ocean. And on the coast, you have suddenly huge erosion going on because the rivers do not contribute the bed load anymore. So these are coupled systems, okay, in nature. And indeed, also in terms of other environments, like here, the volcanic actions, but we are not talking about these and not going into depth in these, or with earthquakes and so forth. But these are not really related to climate change as far as we know at the current stage. Okay, so now we have addressed a little bit the left side of this graph. We have addressed these processes of different types, and that's what we call the hazards if they influence society. But we also have to address the right side of the graph, which is the society in general. So you have the elements at risks, like us as people, or the roads, or the houses, or agricultural areas Yeah? These different elements at risk are differently vulnerable towards specific processes. Yeah. So you might have a house, a wooden house, and the wooden house has sort of a given value. And if there's a very small flood only, the wood gets only wet. That's not really vulnerable towards damage. Okay. But if you have a flood which has 2 meters of height, then this wooden house gets possibly completely destroyed, and then the vulnerability is very high. It's still the same element at risk with the same damage potential, but with a different vulnerability. So if you talk about risk, you have to address not only these processes, which we call hazards, you also have to address the consequences, okay? And that's what we are normally in engineering sciences, in economic sciences, in insurances. You're addressing that normally in this type of equation, where you're having the hazards, and these are the functions together with the elements at risk and vulnerability, which are the consequences. And both of them define the risk on the left side of the equation, okay? So that's what I understand now in the talk when I'm using the term risks. Okay, so now let's go a little bit broader. Indeed, I think this type of maps, which show you the ecological footprint of us humans on the world, the more red, the higher is the footprint of us on the environment. You realize we have a global impact, okay? What I don't like in this graph actually are the white areas between the continents, and I will go to that in the very final stage of my talk. And indeed, this is a global issue. That's also an Austrian issue. We have also here in Austria the human ecological footprint, and there is some development, okay? On the left side, on the top, 1993, on the right side, 2009. And in the lower left side, there is a differences. And red means the human footprint got larger, increased. And you realize that in most areas in Austria, in particular, in the high mountain area, in the valley areas, there the human footprint increased. However, there are also some blue areas, and these are in particular those which have no agriculture anymore, where they have reforestation programs, and that's where the human footprint decreases. But in principle, it increases. Okay. Good. So we have human impacts on the environment. And now coming back to the disasters, to the risk, we also realize that the disasters and the consequences from these disasters, they rise. They rise in total. Here's just a graph which I updated today from the Munich Re. The total with the orange line. So you have still an increase number of events which cause significant losses. However, when you're looking at the different type of events, so you have the climatological events and the geophysical events and the meteorological events and the hydrological events, you realize that they have different tendencies, okay? So you, well, if you're really being careful, you have to differentiate, okay? Differentiate also in terms of losses. And if you talk about losses, you always have to be, again, careful, because you have to differentiate again between the economic losses as a total and the insured losses, which is here on the left side. Actually, the insurance companies are doing a good job because this orange in this bar, in this K graphic, is rather large, which is good for insurance companies because they don't have to cover that. Yeah, the grayish areas, these are the insured losses. So that's where they have to take care of. But again, when you're looking on different type of events, and these are the graphs on the right side, you realize they have different contributions. So the meteorological ones are dominating both overall and the insured ones. Yeah? Okay, and indeed, these economic losses are or seem to increase for different types of processes in terms of environmental hazards. So there is a tendency that they are getting larger in terms of the total economic loss. And this is also here a graph from the UNISDR, which shows you different impacts by disasters. So people affected, the damages, also people killed. But in the lower part, you also realize that there are different countries which are differently affected. And China, for example, with 2.5 billion people affected by these disasters. The US, they have huge economic losses in terms of damages, and Haiti, unfortunately, has huge number of people which were killed in these events. So the impacts are completely different, and they are also varying over time. So here we start in 2000 and goes until 2012, and you have different sort of major events which identified here, which cause sometimes a lot of losses of lives. Sometimes they cause rather many people which are affected, or in the upper part, they cause huge economic effects. In any case, there are huge effects, and this is again globally happening. So it's nothing only in China or Austria or wherever you are. It's a global issue. Okay. So we have to state we are living in a dynamic environment, and we have our environmental system, which is coupled and which is constantly operating, and we have our social system, our society, which is constantly operating and working. And this is coupled, okay? It's coupled, and it goes on and it goes on over space and time. So we are living in a dynamic situation in terms of the environment, but also in terms of the society, and of course, including, if we talk about environment, including the climate. So there are now some very interesting studies being done looking on, well, how does climate change really change our hazards? Okay, and this is a study from Günter Blöschel here from the Technical University in Vienna, published in Science, where he looked on in Europe and looked, well, what are actually the trends of river flooding in time from 1960 till 2010? And what he showed is, well, it's actually not so easy, because in some areas, yeah, there are some changes where you have the floods earlier, where they occur earlier in a year, but in some areas the floods occur later in a year in this period of time. And there are also different reasons for that, and this is on the right side displayed. Yeah, you have sort of the floods, and which are always the green lines from 1960 to 2010. And you have different variables which influence the floods, and precipitation is one, and snow melt or soil moisture. And when you have a look, for example, in the top right one in Norway, here the floods shifted in months together with the shift of the precipitation. Although the snow melt has a different development over time. Okay, and there are different relations which have different signals over Europe. And Günther explored that a little bit further, and he realized that within Europe, in some areas, the importance of different variables vary in Europe. So in Northwest Europe, for example, that's the area 1, you have more rainfall, a higher soil moisture. And in the Southern Europe area, you have less rainfall, but higher evaporation. and in the area 3, you have in particular the snowmelt, which is decreasing. So again, the climate change has completely different consequences for the floods. Okay, and this principle needs to be taken into account. Yeah. At the same time, you need to be very careful. You could, for example, have a look here for the discharge, here for the ESA. This was a very nice study from the Environmental Agency in Munich. From 1926 to 2010, the annual discharge. And you could conclude that actually there is a trend of a decrease, yeah, if you only looking at the discharge. However, there was built a reservoir called Sylvenstein, which is here in the lower graphic, this blue triangle. And here, in this reservoir was built in, or has finalized been built in 1959, 1960. Okay. And suddenly you realize, hey, actually there is no trend. Yeah. There is this reservoir being built, which is on the top right side. And then the discharge itself changed. So the change of the flood and the discharge has nothing to do with climate change. It's just purely related to human impact. Yeah. And when you go further with this argument and looking here, it's a very nice study here from the US. In 1800, the dam locations for rivers, here in 1900, the dam locations for rivers, here in 1950, the dam locations in the US for rivers, and here in 2000. And when you're now looking or thinking about that you purely only look on flood hydrographs to investigate the flood changes in terms of climate change, you might trap in a completely wrong direction. Because actually, the changes are not so much related to climate change. They are rather related to these dams, which have been built, thousands of them. And that's only the example in the US. Exactly the same happens everywhere in the world. But when you're looking on the traditional water cycle, well, where can you see us as humans? Where can you see the dams? A lot of these models which we are using within our environmental studies are still having in mind that we are dealing with natural systems, with natural conditions. But we are very effective, we as humans. Yeah? For example, we start with a disturbing event when we are taking off all the forests, and then a couple of years later, then the next rainstorm event happens and a lot of landslides occur. Then you have this relaxation time until you reached again the equilibrium, the forest grows again, you cut it off again, and then after given a period of time, the environment reacts again. So you have different lagged responses in your environment. So here's a graph from 1850 till 2000, more or less, and then you have the land use change. It's the first bar, okay? And then nothing happened after the forest has been cut off until the next big rainstorm event happened 30 years later. And then you have the mobilization of materials, which reach the bottom of the slope. Another 20 or 30 years later, you have another big rainstorm event, and then this material is moved into the river. And then another 30 or 40 years later, this material is moved into the ocean. Okay, so you have non-linearity in your environment. And you realize suddenly how difficult it gets to relate that to a climate change which happened over the last 20, 30, 40 years. If you have these different responses in your environment. And indeed, you have these responses on the left side in your environment, within your hazards, but you have exactly the same changes on the right side with the exposed elements at risk and the vulnerability. Think about urban development. Yeah, the coastal part, the flood areas, how these are developed. Okay, so in terms of risk, which is always the hazard and the consequences, yeah, they develop together, and we call it, it's an evolution of risk. So in time we have evolution of risk. Yeah, very important. So coming back to the principal idea that we have this natural environment with the variables which interact. On the right side, these human activities, very small. This has been published in 2000, so not 20 years ago. Okay, and I think we can just say this is not true anymore. We as humans are influencing our environment to a much greater extent, as it is expressed here. We are not just a factor. We are the dominating factor. And this has been addressed as well here in this pinkish color, which is now slowly moved towards also into the water and the land use and so forth. Well, it's much better, but still, yeah, our role is much, much greater. So we have to think back, well, what is actually the couple? We have the environment, we have the society, and we have the interaction. And this is what we explore in the environmental risks. So we have the Earth system on top, and we have this human system on the bottom. Okay, and this interacts. But is that really sufficient? Is that really sufficient? I'm asking that question myself constantly the whole time. When you're looking on this type of graphics, this is a graphic which shows you the mobilization of sediment in the US. On the base one, the natural conditions. On the top one, sediment which has been mobilized by us, by humans. That's the same scale. You suddenly realize in the US, the mobilization of sediment depends much more from the human activity than from natural conditions. And when you're looking into the landscapes, well, you find everywhere hugely changed landscapes changed by us. Terracing in China, slope leveling in Austria. Here they have removed a whole hill to build a new city. You have drainage lines which pour the water artificially at specific points and trigger there debris flows or some small landslides. You can see clearly the drainage line here, or here the extent of this landslide. So in a sense, we as humans are influencing our environment in a way that in many cases, we should not talk about environmental system anymore. We should talk about hybrid system. Hybrid system means that these are not purely the physical natural condition anymore, which is on the left side. We are talking about systems which are there because we are interacting. We are interacting the society and the physical world. Okay, so this needs to be extended into the hybrid systems. Okay, so this is a hybrid system, isn't it? Where we influence the landscape tremendously. This is an extreme hybrid system where you have a garbage place, where you have a landslide in garbage, or here as well in Rio de Janeiro. Or here you have a failure of tailing. It's a completely artificial slope, or tailing failure, which causes many, many deaths because it failed. Or if you go in the vineyards, the erosion in vineyards, the vineyards are there because we have planted the grapes. And then this causes erosion. This is a hybrid system. This is not a natural system anymore. Okay. And this happens everywhere. The human interferences are worldwide. It's a global issue. And it's a global issue on land, like here on the left side, but also in the ocean. And we are very active for thousands of years, in some areas for more than 5,000 of years. It's a dark bluish area. And in some areas, we are active more recently. However, we are acting globally. Okay, I just skip that. So coming back to the ecological footprint, I think we also have to look into the oceans. And this is currently quite often completely neglected. We are focusing on the terrestrial systems only. We neglect completely the oceans and our interactions in the ocean, in the water, but also in the surface of the oceans. We are influencing that already to an incredible case. So not only in terms of plastics and or the distributions and increase of water, no, also in terms of our activity on the seafloor, for example. So we have non-linearity, we have delayed responses, and we have different forces. I will not go into that. We are often still thinking that if we understand the present and what we observe in the present is the key to the past. Well, I'm actually not sure anymore. I'm not sure if what happens here today can really be extended to the past. And the past is the key to the present. What happened thousands of years ago, 2000 of years ago, is now currently operating completely differently. And I think I've shown you many examples. And the principal idea that if we understand the past and the present, and these are then the keys to the future, I don't know. I don't know if this is really true. Because I'm raising the question if the future is completely new. And this has huge implications. This has huge implications for all our measurements, for all our modeling, for all our scenarios until 2100, which are important. No doubt, they are important. But possibly we are just using the wrong models. And climate change is indeed very, very important, and it is addressed globally, it is addressed here in Austria with the CCCA, for example. And indeed, there are international reactions which are really, really good and helpful. There are many publications on climate change issues. However, we also have to focus on the environmental risks. There are some initiatives here in terms of the disaster risk reduction, in terms of the sustainable development goals, and also initiatives to bring these together, the Sendai framework in disaster risk reduction and the sustainable development goals. And we have to go beyond that. And I'm really sorry, but climate change is not the only challenge for us. We have to link that really to other issues in our environment as well. We have to link that to our activities, because besides what happens in our climate and in the changes which are there, and I want to say again, no doubt we are facing major climate changes, but we are also facing other incredible changes in our environment, which are sometimes forgotten. Okay, so there are some take-home messages. Indeed, the climate change is evident in all dimensions and spheres, but environmental change as well. We should not underestimate us as humans. We are modifying existing conditions and we are creating new ones which are not known yet. These occur everywhere in the world. There are new emerging processes related to human impact. And the big question is, what are the tipping points in our environment, in our climate? How will that change in the future? What is the human dimension herein? And again, indeed, we have the climate change, but we also have the changes in the environment and the related environmental risks. So environmental risk in a changing climate, this will be, in my opinion, a major topic for the future. Thank you very much.
Wow, thank you for these provoking thoughts. And thank you also for explaining the topic of environmental coupled systems and risk in such an understandable way. to us all. So interesting to learn how everything is connected. The insurance companies that you mentioned, but then also the number of people who are affected in the various regions. And I was personally impressed by the example of the US reservoirs, and how humans keep changing our environment in such a fast pace. Yes, so
yeah, sorry for extending that a little bit, and I'm also only used a couple of examples, but you can transfer the main message to every kind of hazard, natural hazard, and to all over the area. And I want to focus also and bring to your attention that a lot of things happen in the ocean as well, and people tend to forget that. Yeah.
Yeah, so dear students who are still here with us, you can start writing questions or comments into the commentary section. And while we are waiting for those, there is already one. Good, otherwise I would have started with some. So Nadine Kaltei, she asks, I have a question about the floods of the Danube. In the Wachau, for example, you can see the flood protection wall very well. What damage does such a wall hold? Are these a reason why the floods are getting higher and higher? Would one solution be to create more flood areas such as the Danube floodplains, or are there other solutions?
Yeah, in particular with the floods, it's a really good question. We are facing huge issues because of the costs. You design these dams based on different recurrence intervals for the floods, okay? And this is a political decision for which recurrence intervals, or for which flood height you want to protect your people. And there are two major drivers in changes in the flood heights. One is indeed the climate change, in terms of that you have more intense rainstorms, which remain stable and pour a lot of water into our catchment, much more than we experienced before. So you have more water available. At the same time, over the last decades, you have sealed the area. So the water is not going into the ground anymore. It is flowing on top, directly into the river. So the time which a raindrop needs to reach the river gets shorter and shorter. And when you go down into an catchment, yeah, so the water goes quicker and quicker into the river, and therefore the stage height raises and raises the far you go away from the actual source. Yeah, therefore the dams, okay, are possibly designed by have been built 50 years ago or 40 years ago, and there we didn't have these conditions, and now they are not appropriate anymore, so they have to be rebuilt, and this costs millions and millions and millions of euros. And that's why in some areas, also in Austria, they decided to take away the dams again, to give the river back space for flooding, and to move the people away from the flood areas. This is much cheaper and much more sustainable than constantly increasing the height of the dams and having all the maintenance costs. Okay, so there are always these two levels: the natural conditions, like more rainfall, yeah, but also then this human interference and the human changes. Okay.
Mm-hmm. I'm wondering, is it then difficult for people to move away? It's like
absolutely, it's a huge discussion
because they have that emotional connection then to land.
Absolutely.
And
I never said that this is easy. Never. But there are some areas where they have implemented that successful, because some people like that as well. Yeah, they are getting some compensation. They are getting then suddenly some very nice and new flashy houses somewhere else, yeah, but not all of them like that. Yeah, big debates which are going on, but I just wanted to show that there are different solutions, but very difficult to address. But I think this will be the future.
Let's take one last question. I see my colleague Martin has posted into the chat, and I will read it out loud now. Would you say that environmental risks are related vulnerabilities are shared equally over the globe against the background of climate and environmental justice and injustice? I have the impression that people in the global south, not having caused the crisis to a comparable extent, are much more affected by disasters. Is there, in your view, a pattern like that?
I think this is a lecture series in itself, this question, to answer that. In principle, well, we only have now a minute. I would say yes, you're right. This is the case. We are facing problems here in Europe as well, in our industrial areas with drought, with health issues, also with flooding. But in my opinion, nothing in comparison to what the people have to face in the global south. And indeed, there is in terms of global economics, and there are many, many relations which could be explored here. And I would say yes, the people in the global south are more vulnerable on one side, but also more affected by the environmental changes. And some of them are really initiated by us. Think about Stephan Glatzel's talk with the peatlands. Yeah, why is the deforestation in the peatlands? Yeah, in Indonesia. Yeah, because we have our food with palm oil, and they need the area to build the palm oil. So it's a complex matter. Okay, and therefore, in principle, I would say yes, you're right, Martin.
Okay, thank you so much. And I'll now hand over to Martin again, and he will introduce our fourth guest of the day.
Yeah. Thank you again, Thomas, for being here today. Thank you for the talk. Thank you for the answers. Thank you for the presentation. Last but not least, and in this case from a different perspective, that also points to our class title today, namely actually climate change research across different disciplines, I would like you to welcome Laura van Praag. Laura van Praag is the head of the Center for Migration and Intercultural Studies at the University of Antwerp. She obtained a master and a PhD in sociology at Ghent University. Her research interests are environmental migration, ethnic minority success in education, and qualitative research methods. Laura will speak today about environmental migration and displacement, an issue that could not be more important to consider these days, especially against the background of the tightening of environmental injustice, also due to environmental change and climate change. And this also maybe points a little bit to the question I just posed. And I think when it comes to environmental risks and also different vulnerabilities, that her talk will be quite related in some way to this talk we have just heard. I'm very much looking forward to your talk, Laura, and the floor is yours. I don't see you at this point. Now I see you. That's good. Thank you very much for being here. And yes.
All right. Thanks a lot for inviting me, and very nice to see you all present. You hear me well? Just a usual question. I will immediately start indeed to talk about environmental migration and displacement, but I very much liked the previous talk from Professor Glade, as it also introduces some points that I want to raise indeed in my presentation. I will share my screen, and yes, I hope you see it all now. So first of all, I think, and you might have heard it also in the media, some from NGOs, climate change and migration are both hot topics, and they're both high on the agenda. So the combination of both is also high on the agenda, and it's also very much debated. It's often a topic, and it's also often used as a way to actually sensitize about climate change, stating that the consequences are very high for a huge number of people, makes you also think that it is important to think on climate change and how to mitigate it, but also how to adapt to climate change. I think from here on, I still agree, of course. I think indeed climate change will affect the lives of many, many people. What I do want to show, and maybe I'm giving away the key message already, and we just started, but I hope you keep on listening. But the main thing is that the image sometimes, which is shown when you see all these media articles and on climate refugees often, or on migrants, is that it looks like people are suddenly out of their houses and that there will be floods. Often you see people on boats coming to Europe. And I think it's important to nuance a bit and give a more actual view on how climate change will affect migration and how we see it already in the past, because it's of course not a new phenomenon that people migrate due to climatological reasons or to adapt to their environment. And I think here, so I start with climate change, but I will already start with the previous session and say that indeed for your migration, it doesn't matter what the actual reason is. If you see environmental changes that are detrimental for your livelihoods and for for survival, then you will or you want to migrate. And so therefore it's often, let's say, I'll continue on this a little bit further, but I think it's important to also not only look at the pure climate changes, but look at all environmental changes and know that there is also like an interaction with human interactions. And so my apologies, that it's also important to consider that it's often an interplay of different factors that cause people to migrate. Now, when we look at these the debates, maybe you have heard of them, you see that both left and right-wing politics use actually this imagery of environmental migration or climate refugees. Right-wing politics will say, like, let's now close the borders, let's stop migration because there will be many more in the future. And at the same time, left-wing politics will rather use it to sensitize more on climate change and to rethink also ongoing migration policies, which currently do not consider any type of environmental changes. It's also important that you see that, to know or to think of it, that often the term climate refugees is used, but as for now in the Convention of Geneva, the term refugees does not include any type of environmental change, which means that actually climate refugees is kind of a term used for wishful thinking, but it does not apply necessarily to refugees yet. And it's more like a claim to change those migration policies in order to include also people who have to flee due to environmental changes or climate changes. So it's important to know that when you talk about climate refugees, it has some connotation in it, but because you want to change something. It's, of course, it's not good or bad, just to know that that is the actual meaning, because it's not yet there. That's why I will talk now in this talk more on environmental migration, whether or not what my intentions are, or whether I think it should change or not, because that's what we know and that's what people are. They are already migrants because they have to move or due to environmental reasons. Now, in most, also in other lectures, I showed this these slides. Sorry. To show also that there are various reasons, and probably in this series you could have already imagined it, that there are so many reasons why people could change or want to migrate due to environmental reasons. And when we start, for instance, left on the top, you see that in the desert there was sudden snowfalls. It's an unexpected change. It's a weather event which is unexpected, and because of the fact that it's unexpected, and I think in Austria but also in Belgium, from one day of rain people do not expect to die. But of course, if you're not prepared, at night it can be very cold, and if your cattle is outside and it's after a couple of days of this snow, some have passed away, it could have huge effect on the ways, for instance, nomads lives in these deserts. So you should really understand how people live to understand the impact these environmental changes or events or weather events have on their lives. So a sudden snowfall could be more disruptive in a region where you don't expect it or where you're not prepared, compared to, I think, in Vienna or in Antwerp. The second one, it's of course a little bit for the show. It's from Shutterstock, but it shows that people, that there used to be a lake there, and due to also economic production, this is, for instance, a place where there used to be a factory that used a lot of water to make cotton, and that's why the combination of changes in the environment makes that many fishermen had to migrate. The third image from the top, if you go left to right, is in India, where there are monsoon rains a couple of years ago, and they caused huge floods. The monsoon rains are predictable, but they were heavier than before, or then heavier than expected, which could be due to climate change. At the same time, there was a kind of miscommunication, let's say, in the water management, and all dams in the environment were open, which made it that it could be prevented, but it wasn't prevented at that time, and that's made that many people had to migrate from where they lived, and it caused huge floods. The fourth one is actually, you see, a more traditional way of getting water in underground rivers in Cataras, and it's a traditional way of getting water already for many years. However, those Cataras, they have less and less water due to drought, and at the same time the living standards change over time. So maybe it was good, but you cannot buy a smartphone from this work, and people prefer to opt for other livelihoods and maybe decide to migrate. I think of young people that say, like, okay, actually I now want to go to the big city, I want to study, I want to do something else. Like maybe many of you also want to study something else as their parents and do something else. So it does not necessarily mean that people have to flee, but it could be also a reason that has to be taken into consideration, changing standards of living. Below, you see on the left, it's actually Flanders, but it could be also in other regions, of course. And I just want to show that also there are some floods here, well, in my case, in Belgium, and people don't see themselves or consider themselves as a kind of climate refugee or environmental migrant when they go and temporarily live with their relatives in the environment. However, this is of course a similar event and could happen everywhere. And it's just forces you to reconsider how we should think of this environmental migration. It also is often a temporary type of migration, and people maybe want to sell their house but go in the environment and go by somewhere else where they have less risks, maybe only 5 kilometers away. So it shouldn't be like the biggest changes, and for sure it's not that these families suddenly all migrated to another continent. Well, the sixth picture is the one from the Syrian war. It's often highly debated whether or not there's an impact on these climate changes before the war due to drought and due to famine, which makes that every refugee coming from Syria could be considered as a climate refugee. However, you see that it just plays to other factors. It's hard to, of course, to really state, oh, those are climate refugees, because these impacts are hard to measure. Wouldn't there be political conflicts without the drought? How can you know? We'll never know, which makes it also hard to categorize people as climate migrants. And the seventh, maybe they're better pigs, but this is actually an island on the Kiribati Island in the Pacific Ocean. And it's one of the most, the first groups of people who will migrate due to the sea level rise. And they're already asking for some kind of protection where the community can migrate, for instance, to Australia, New Zealand, or some countries in Asia, because they know they will have to migrate within 50 years, and they just want to do it organized. However, it's very hard because they never get recognition yet, or there was recently only the first attempt that there could be some recognition, but it's very hard because if you allow these small islands, you say like, okay, how many people are they in Australia? They have enough space. How hard can it be? But of course, if you change the law, the door opens for many more migrants, and those countries are not really willing to do that. And then finally, that maybe relates to the question of Martin on climate justice. And I think throughout the presentation, you should think of it like, yeah, whether or not it's not only fair to change migration policies, since it's an unequal distribution of those who contribute more to climate change, and also actually the ones who have to migrate. So what I already mentioned, and I think you will see it very clearly, it's very hard to categorize this group of migrants, which is important if you want to make policies. And this is one of the first attempts where Bates tried to categorize depending on the type of environmental change and the cause or origin. Well, this is super hard to make, and in the end they had to abandon those kind of classifications, because what does it matter? The effects are, first of all, the same, and second of all, it's super hard to categorize a disaster into one particular thing. Often there are many things that happen at the same time, at the same place, and what is the worst? If you had a flood, also more drought, and also changing living standards, yeah, what would be the reason that you want to migrate? Once there is actually a legal framework, of course you will focus on that, but since there is not, it is very hard, and people will not really think of it. And it's also, well, think of it, I mean, like you should also be aware of it. You should categorize your environment in the same extent, and it should be maybe done even by policymakers. So they try to make up a classification, but by doing it, like what is the intention of migration, it's very hard to classify, because yeah, if you're maybe people would have stayed if it's very attractive in the place where you live and there are many opportunities to work. Well, if that changes, of course, maybe you want to migrate, but is it intentional or not? Do you want it? Is it voluntary? What is acute, gradual? How long should you count? If it's 50 years, there were maybe more other ways to adapt to climate change. So I'm sorry, I'll just keep time. Okay. So the International Organization for Migration tried to set up a definition for this group of migrants. However, if you look at the definition, environmental migrants are persons or groups of persons who, for compelling reasons or sudden or progressive changes in the environment that adversely affect their lives or living conditions, are obliged to leave their homes or choose to do so, either temporarily or permanently, and who move either within their country or abroad. Actually, this spans a huge amount of people, and I think they are 100% correct if they say like this is the best possible definition of environmental migrants. However, this is also a very difficult definition to put into practice, because actually you would be saying that nearly a huge amount of people would be environmental migrants, actually almost large proportions of the world, which I think for policymakers, it's hard to accept that this would be the actual group of environmental migrants they would have to protect. It's also, for instance, more harder to get grip of temporarily migrants. For instance, they don't always change their address. They stay with relatives. If it's within the country, it's often hard to know what is their reason to migrate. So there are some additional hindrances to really protect. I know in Belgium, it's a super small country. It doesn't matter how far you go. Maybe in other countries which are bigger, you see that people migrate really from one region to another. And there you could maybe get grip of some migration patterns, but still it's very hard if it's not tracked or kept administratively. And also if you don't have to ask for asylum, for instance, or protection, then you just move and that's it. So it's hard to know how big this group is. Now, and this is one of the most influential models. I know it's a lot for now, but in this model, it's made by Foresight. It's a Foresight report. It just wants to say that environmental change impacts most drivers of migration, and these environmental changes could be very diverse in nature, gradual, sudden, also actual and perceived, which is also very important. Drought is harder to perceive compared to a flood, for instance. So how will you know that there has been a change? You really have to keep scientific records or know it from the media or from statistics, actually, because some things are harder to know in everyday life. But then they have an impact on political, social, economic, demographic, and other environmental reasons to migrate. And one of the most common is, of course, to foresee your livelihood. If you don't gain enough income, it's clearly visible. Political conflict is also more easily visible, but still they can both interplay with another, and therefore it's hard to really get the portion of the environmental effect out of this group. It doesn't mean it doesn't exist, it's just harder to study, let's say, or to put in policies. And then it impacts people differently. So it impacts not everyone in the same extent. Think of the one who lives on top of a mountain and the one who lives in the valley, and there's a flood. It will have a different impact living in the same region, in the same country. Also, when you think of drought and you're in agriculture or you are a doctor, it does matter. It is a different impact on your profession. Also, if you're young or when you're old, let's say you have your entire family already living, think of your grandparents. Are they willing to really move still, or will they prefer to stay, compared to young people who, or how hard they already want to explore, and maybe they find new opportunities elsewhere. So there are many personal household characteristics. Sometimes you see also that migration is a household decision. And so because of that, you see that they try to diversify the household income. And because of that, they say, like, okay, maybe one goes, we put all our money on this one. Let's say, because migration costs money. You have to travel, you have to find a new place, you will not maybe have an income immediately. So maybe they say, okay, one goes. So if something happens here, we have a backup, let's say, in the city or somewhere else. And sometimes there are some facilitators, like existing migration networks. Let's say I did research in Morocco, there was already large diasporic links. it was easier to then move, let's say, to Belgium from Morocco due to relatives or also due to family reunification procedures, which made it easier to migrate compared to families who did not have such linkages. So still, there is always a decision to migrate. Will you stay or not? Will you be able to migrate or not? So also the poorest families do not have the means to migrate, which actually leaves them in a very vulnerable position. And these immobile groups also deserve our attention because they're not protected, they're not feasible, but they stay and they already did not have enough means maybe. So also the richest households will not migrate because maybe they're the ones living on the hill, they have already better protection, etc., etc. So that's, I think, the main thing. It affects everyone differently. So these environmental changes, which also translate in a different, in different migration decisions. So this is, well, actually what I already said. Also, it will have an impact on these migration routes. And if you look at the migration trajectories, that you see that they're mainly internal movement, short distances, people rely on social networks, it's temporarily. So transnational migration is rather exceptional. This is not what you see on those pics with boats of migrants coming. Also, many people return, especially when it's temporary migration, they return after or to rebuild their region. Also, depending on the environmental changes, you have a different degree of migration. Some are more urgent, or they result in different trajectories. Well, I'll go slightly quicker. There is one interesting approach, if you also look at climate adaptation policies, is to see migration as a potential adaptation strategy. And if policymakers support particular groups to migrate, they could diversify incomes, but also reduce some risk on this region of origin. For instance, to have too much people living in the same spot, to have a different impact to reduce its impact on agriculture, but also they could help, their networks could help to actually develop alternative adaptation strategies. So it could be seen as an adaptation strategy, but it has to be very carefully monitored, which is often not the case. So it's often could also be a maladaptation, because if only the hard, let's say the young people go and you're left with an imbalance in the population, it has also its results. So depending on that, maybe not all migrants are able to send remittances back and some money and resources back. So, or they're not aware of these climate changes, etc., etc. I will maybe go slightly faster, but this slide just shows that the climate changes and could have, depending on the type of climate change or environmental change, you could have a different type of migration. Depending, let's say, natural disasters often lead to temporary migration. The sea level rise, such as the Kiribati Islands, could depends on the regions. Often they affect coastal areas highest because they're also very highly populated, like many cities in the world and the small islands. And also water shortage, which is has the biggest impact, but it's often impacts people on less consumable water. And also the impact on migration is also very unpredictable. I have also one small example, which is the Hurricane Katrina in the Gulf of Mexico. And there you also saw that they did not expect, so there was a hurricane, and it was high. It was even in a season where there are a lot of hurricanes, but still they did not expect that it would strengthen the inequalities, the existing inequalities, and that many people did not return. And they thought everyone would return, but they did see that people who own the land would return faster, that actually poorer groups stayed because it took so long to rebuild, they stayed in the new place where they had already new jobs. They saw that there was a lot of reconstruction, a rebuilding of the land by actually illegal workers, while some other unemployed groups said like, yeah, why do we even return, etc., etc. So it actually strengthens more, I'll skip these, it strengthens the existing inequalities of a region already. And that is something you need to bear in mind when you think of it, also thinking of those immobile groups. So if to take away from tonight, I think it's important to rethink how can we best protect these environmental migrants? Should we add climate change or environmental change to this convention of refugees? Should we go for something else? Should we rethink the entire migration policy? How should we do it to make it fair globally? Should there be some environmental justice where the countries who contribute to most also consider migration or invest in some climate adaptation elsewhere to reduce the vulnerabilities of people? It also does not only happen outside Europe. I think it happens everywhere, but people have more resources often to adapt. So you can see together with other adaptation strategies, if let's say in the Netherlands, they build dams, but they still construct houses in water. Actually, you cannot imagine how weird that is. While people as in the Kiribati Islands, they have to move. And so how do we consider that? And shouldn't we also apply to Europe? And also, I think I put environmental justice twice. How should, well, in debates on these environmental migrants, I think it's important to consider the actual migration consequences, such as these internally displaced groups, immobile groups, to really capture the real vulnerabilities, the fact that it exaggerates and strengthens existing inequalities. I think that needs to be considered as well within policies. Well, I'll stop sharing. Thanks a lot for all your attention so late. And I'm open for all questions. Thanks a lot.
Thank you. Thank you very much for this brilliant talk. Thank you for showing up the complexity of the issue and also the difficulties with the terminology and all these things. And I mean, all the questions you have very posed in the very end, that's something we could now discuss for days and weeks actually about it. And I'm just, we still have 10 minutes for discussion. So I'm just inviting all our students and participants to post some questions maybe, or maybe even some of us want to try to answer maybe one of the questions you posed in the very end, or at least to think on that. Let's see what comes up in the chat. I would also I have a question in the meantime. You have mentioned this in the Geneva Convention, of course, like the term environmental refugee is not a thing. Do you know, are there any efforts on a policy making level to change this, or maybe to, you know, to amend the convention? Or are there any countries that are specifically progressive in saying that we accept this kind of migration or flight? Do you know what's going on there?
Yes, well, I think the fear of changing the Convention of Geneva is that you have to abandon it, and then every other member state has to sign it again. And people fear that then we will lose even more protection of vulnerable groups. So that is often, although it's often hinted at, like climate refugees, I think it's not really at the table, or, well, from my perspective, how I see it, because it has too much risks. What they try to do with the United Nations Migration Pact is what they wanted to include it a little bit, but it got skipped out actually due to some of Belgian politicians. They feared that it would bring along too high number of risk of having migrants. They're a more anti-migration party. Another thing is that there is some kind of non-binding internally displaced persons protection, but it's very hard to implement it, and it doesn't have so much power, especially because of its non-binding nature. But it could have some, it could be some interesting thing to think of that, and to look at this group of internally displaced persons. And then there is some recent, there has been some countries work also differently legally. And in New Zealand, I think there has been a first acceptance of one of these Kiribati Island migrants who won some legal fight. And I think this is a first start, and everyone looks at these islands as a start to change also the law, because some countries built further on that. So I think if there is something innovative there from in that region to be found, and I think it's highly on the topic, but then when people want to implement it, everyone fears that it will bring a huge rise of migrants along.
Thank you.
There is a question in the chat.
Yes. I think Laura is already reading it.
Yes,
It's very long.
Well, I do certainly agree that there are, let's say, there are difficulties. This is more like the practical side to categorize people, but I do personally propose a more regional approach, because then you can really say like, okay, this area is hard to live. How shall we deal with the particular socioeconomic situation, environmental situation, political situation of this group? Because most people do not want to live away from their relatives and their networks. And I think it's a great strength. So if you look at it more from a local perspective, which is, I think, often the case with climate adaptation, it's a more regional approach, which makes it also tricky, because then there is less to say from these global IPCC reports and everything, because then it becomes to be like something like, you have to look at it from the local side. But I think if you approach it very well, it has a lot of power, because then you can consider most things and also monitor a little bit this migration. And then if you really implement it like that, then this migration as an adaptation strategy could really work. But otherwise, if you let it flow automatically, personally, I think it could not, it will also often have some side effects. We could be also detrimental for people's livelihoods. But indeed, you're right. We need to support those large developments. I'm 100%, I 100% agree. But then you should also ask the question, who should start those developments? Who should support them? Who should make the frameworks? So maybe at global level, you can develop larger frameworks to support and give many people or many countries also at a local level more inputs to do that. But indeed, of course, we should do something. I hope my talk did not say like, yeah, it's hard, let's stop. But you're right.
Thank you very much. No, not at all the way I've understood it. So, and very, very good questions and further things that we should ponder on and also fight for. Are there any more questions coming from the chat or comments? Yes, there is one from Vera, and I just read it out so that we also have it on the recording then. I wanted to ask if you know how climate justice and the vulnerability of regions in the global south to the climate crisis is already considered in post-colonial studies, or how the connection between colonialism and vulnerability in various ways is already discussed. That's a very good question.
Yes, I agree. It's a very nice question. I think in most social sciences, environmental issues are only recently introduced in a way. So it's actually, although it has been on the agenda, but still I think it's relatively understudied compared to other fields. and especially the interaction with other fields. So then it's like environmental sociology or some sub-disaster anthropology or some sub-team. And I think it's insufficiently incorporated in some other branches. There is a thing when you think of this colonialism, the fear to redo colonialism or have paternalistic thoughts about this, because often it then turns out to be some, I don't know how to put it, and there has been some thinking, some critical thinking here and there, but it's more like if you do climate adaptation where it's not locally led, it could indeed turn into some post-colonial or a colonialism kind of way. So that's why that's why this locally led climate adaptation has so much strength to avoid it. But then you should really rely on these local structures, and you have to undergo the same processes in many similar regions in a similar way. So I think there could be a lot more to be said on that. And it's relatively new, I think, but I'm not an expert in this topic, but still it's not fully exploited how it could be. I think it could be more. And a final thing is I think the last years there has been more research, but they often like this the approach to see migration as an adaptation strategy. They really go to the terminology of policymakers on climate change, and then they it's hard to go back to the social sciences because they want to impact the policy because that it's urgent, and they want to get through and use the same terminology of these climate change policymakers, but then you see that they also are often not so well integrated in some other branches of the social sciences. But that's my personal interpretation of this development of the fields.
Okay, thank you very much. The time has already proceeded very much. So maybe I invite Laura, maybe there's one more question by Raphael, and maybe you can respond to it in the chat if you want to, because
Okay.
we have to sum up and do a short outro, and I will hand over to Ria. Thank you again very much for having been here and for your talk. And yeah, we look forward to visit you in Antwerp when we're passing through then. Okay.
Okay, so now I'll try to speak very slowly so that you can answer that question. No, just kidding. So I think we are slowly starting to grasp the dimensions of climate change as we get these insights from all these various different perspectives. And what a great third session, and thank you all for your contributions. Now we will start a very well-deserved Easter break for all of you, because our next session will be on the 15th of April. So you have 3 weeks of a break now, and in the next session we will engage with the topic of We Talk, and we'll hear from different educators and organizations about how they communicate the topic of climate change to a broader audience. So next time we look forward of having a speaker from the Ban Ki-moon Center of Global Citizens. Then we will have someone from the University of Antwerp, and we'll have a person speaking from Generation Earth, from WWF, and also someone from the national parks of Austria. So you can see again, it will be very different from this time, but as we have learned until now, it's so important to look at this big topic from all these different perspectives. If you have any questions regarding course formalities, then please check the Moodle, or you can also contact Martin or me via email. On the Moodle platform, you will find all the information, the reading material, and also the link to the previously recorded sessions and the instructions of how to complete this course if you want some ECTS for it. With that, I say thank you and enjoy your Easter break, and don't forget to go out for walks, and see you in 3 weeks. Goodbye.
Bye, thank you.